we have convolution layer, and then we have dense layer. So what CNN actually does, what the convolution layer does is it transforms the data into one shape to another. So if you have a 3D image, or if you have, 3-channel image, a colored image which has R, G, and B, so it is going to eventually transform the data and reduce its dimension and find out the key feature within the data, so that the model has to work less and find more attributes within the image, so that it can be classified with a great accuracy. So some machine learning model includes this particular in the modeling itself. But if you are doing it before creating or executing the machine learning model, then in that case, what will happen? The burden on the model will reduce, and also the problem of overfitting and underfitting will also not will be better, right? So again, what are the techniques that we use? So first one is the one-hot encoding, then we have binning, and then we have polynomial feature creation. Let me just go through one by one. What is one-hot encoding? So let's say, let me just share you another OneNote screen to just make you guys understand what is one-hot encoding. So let's say if I have a particular feature again, let's say I have a gender feature, right? In this gender column, we have, let's say, male, and female, right? So what we will do is, in case of one-hot encoding, there is also something called label encoding. Let's understand the label encoding first. So within label encoding, what we will do, we will give these numbers, these things, a particular number. So for example, some machine learning model, or most of the machine learning model, does not take textual data or objects, right? So they take numbers. So what we can do, we can create a mapping. We can create a dictionary that male belongs to 1, female belongs to 0, or vice versa. You can also do that, right? Male belongs to 1, female belongs to 0. So what will happen? Everywhere there is a male that will be replaced by 1, and everywhere there is a female that will be replaced by 0. So this is a very easy to get and easy to transform way for this. So this is called label encoding. Now there is another way that is called one-hot encoding. One-hot encoding. So what is one-hot encoding? As the name suggests, one hot. Hot means 1, 1 means 1. So there will be only one in the data. For example, let's say in the gender we have male and female. So what will happen? I will create an array of 2 values, right? So an array of 2 values. Let's say 0, 0. So there will be 2 places. Actually, I will not write 0, 0. There will be 2 places. Okay, 1 and 1. Now, when it is male, one of them will be 1. So for example, this one is 1 and this one is 0, right? And when it is female, the other one will be 1. So this is 0, this is 1, like that. This is in form of vectors. What we will do in here is, we are going to create 2 new features in this case, one for this and one for the other. So for example, this gender column is going to be diluted into 2 different columns. First one is for the male, and the second one is for the female, right? In the male column, wherever this male appears, it will be 1, and otherwise it will be 0. And in female column, wherever the female appears, it will be 1, and it will be like this. So only in these features, there will be only one of them will be 1. Remember that. Let's say this is in case of we have only 2 values. If we have more values, let's say 3 values, I would say male, female, and let's say third gender, I would say transgender, right? So what will happen if there is a data set for a transgender? So all these 2 values will be 0. Let's say another feature will be created, and here it will be 0, and here it will be 1, and these 2 will be 0 in fact. So remember that only one of them is going to be 1 in these all 3 formats, and if there is another 4 1, then again another will be added, and that will be mutually exclusive in that case as well. So this is what is called the one-hot encoding. So now that we have understood label encoding, we have one-hot encoding. The other one is called binning. I will tell you, binning is used in most of the algorithm that we learn right now. Is one of them is basically this decision tree and random forest. What exactly happens in the decision tree and random forest is that, because the decision trees actually works very, very good on, on, I would say, categorical data. Categorical data set means there is a distinct category. So let's say if I have a continuous feature, right? Let's say if I have a continuous feature, let's say I have, I would say the marks of the students, or I would say the percentage marks obtained by the students. So percentage mark is going to be 0 to 100. So now that particular, this particular number is going to be any value in between these 0 to 100. Now what will happen? I'm going to take a bin, right? A bin means I am going to define them into grades. Grades are nothing but the bins. We also call it small ranges. So let's say 0 to 33, we call it 0 to 33%, we call it F. That's what we failed, right? And similarly, 33.1 to and 33 onwards to, I would say, I'm not exactly sure. Let's say 50, we call it, let's say, E grade, right? And so on and so forth. Like again, 50 to 60, we call it D, and then 60 to 70, C, and so on. Like 70 to 80, I would call it, let's say 70 to 85, I will call it B, and 85 onwards, I will call it A grade, right? Or let's say 85 to 95, I will call it, A, and then 95 plus, I would call it A plus, right? Like that. So I have actually divided these into a particular bins, a particular small ranges, and then I am using this data. So this continuous numerical value that we have, so any value which is going to fall into this range, that will be converted into F. Any value that will be falling into these different ranges, that will be converted into the corresponding value. So this is called binning, right? The next feature creation was the polynomial features. So how do we create actually polynomial features? So let's understand that. So polynomial features are very, very crucial if you understand the, regression models. So in regression model, when we are going to actually, create a polynomial regression, so we do nothing but create the polynomial features and do the linear regression on that, right? So I will just write. So let's say I have, X feature. So the equation of a line, we have X feature and Y predictable. So equation of a line is going to be Y is equals to W1X plus W0, where this is nothing but the equation of a line, Y is equals to MX plus C, right? So now this M is nothing but a constant, and C is nothing but a constant here. So I have taken W0 and W1. I would say variable or constants, the weight I will call it, right? So in this case, Y is equals to W1 and W0. If we just add more features, what is going to be, let's say it is going to be more feature, Y is equals to W1X1 plus W2X2 plus W0 and so on, right? And now if the same feature, I create another feature, this X2 is nothing but X1 square. If I ask that X2 is nothing but X1 square, so it will be W1X1 plus W2X1 square, okay, plus W0. So now this is nothing but a polynomial regression. But what we did is that we created another feature by squaring it up. This is called polynomial feature creation. And as I told you that polynomial regression is nothing but polynomial feature creation plus linear regression, and that's what we call polynomial regression. And this gives us a very, very good improvement in the result, right? So that is what happens when you actually do these things. And as I told you multiple times that you might not be getting this, algebraic formulas and all. But when you join our master class, these are the things that we are going to teach from the beginning, from the scratch, understanding everything, and then moving forward. Then you will find that everything is fitting in your knowledge gap. So wherever you are not understanding, then these things, small things are put those gaps. And then if you learn your knowledge, if you build your knowledge based on that base, that will be a very, very huge concrete, and you can actually learn anything if you have that a strong base, right? So in that master class that is collaborated with IIT Roorkee, then everything will be, we will be going through everything in a very, very detailed fashion, right? So yeah, moving forward. So these are the three different, I would say, these are the three different ways through which we create the features, right? So we actually talked about one-hot encoding. We also talked about the label encoding particularly. And then we talked about the binning and we talked about the polynomial feature creation. Right. Now, let's have what are the feature transformation actually. So overview of the feature transformation. So feature transformation is nothing but involves alteration or scaling, distribution of a feature to make them into a particular ring. So what happens in real life is based on some value, some column, let's say the variance of the column is nothing but the useful thing to take, right? But when we have one value is very, very high range, I'm not talking about the variance. Okay, I'm talking about the value range. The value range is higher for one feature, and the value range is lower for one feature, right? If I say that the age and the income, if you see the age has only 0 to 100 range, but if you see the income can be literally anything. Someone's income can be 0, someone's income can be 1 crore, 2 crore, someone's income can be 100 crores, right? So the variability in these two features are very, very different. And not only the variability is the main thing that we capture in the data when we learn, but not this variability actually, but the range of the values itself are very, very different. 1 to 0, 1 to 0, sorry, 0 to 100, and the other one is going to 1 crore, 2 crores, or 10 crores, even 100 crores or 1,000 crores as well, right? So these are nothing but I would say some different things. Now, in order to tackle, so what will happen if the model is going to learn based on that? So model will have different influence on these different features, right? Not because of their variability, but because of their range scale values. So what we do, we try to scale them, right? So we try to standardize them or normalize them, right? These are the two ways actually, right? So for example, first one is the standardization and the second one is the normalization, right? We actually try to standardize the features so that we can bring them into a particular range. There is a formula, simple formula for that for the standardization, right? When we standardize our feature, what will happen? The mean of the feature is going to be 0 and the standard deviation of the feature is going to be 1. So and henceforth, every data will come into a certain known range, right? Not in the range of 0 and 1 or -1 to 1, but into that particular range itself, right? If it has huge amount of variability, then it will go maybe -10 to +10. If it has less variability, then it will go -1 to 1, right? The second method is the normalization. Now, normalization is a method in which the data will be changed into a range of 0 and 1. Now, if the data is going to be changed into the range of 0 and 1, then what is going to happen? Again, the every value that we have, this is called min-max normalization. So the maximum value will be, will change into 0, and the minimum value is going to be changed into, maximum value is going to be changed into 1, and the minimum value is going to be changed into 0, and every value in between is going to be changed accordingly, right? So again, that helps when the feature have different unit of ranges and the above one as well, right? These are the two ways. I will also show you the formulas for this vessel. And if you want, formulas, again, I have told you guys multiple times, do not, feel shame while Googling the things. Googling is the must skill that one have, right? That one can have. So Googling in today's day is a very, very good skill. You just can Google the stuffs online and find your answers and then proceed with that. That is the best thing. Now, how can we handle the skewed data? So there are three types of problems. First one is the scaling problem, normalization problem, and the skewed data. Now, addressing the skewed data by applying the transformations such as log transformations. For example, if your data is left skewed or right skewed, then you can actually apply the log transformation based on the X value that you have, and then your data will be minimal, right? So mitigate is what it does. So not only the log of transformation, you can also apply the exponential transformation as well. So these are a couple of ways that you can use to handle the skewed data. And this what will do is it mitigate the impact of the outliers and improve the model performance. So what will happen if you have a very, very highly skewed data set? So the other side of the data will be considered as an outlier, right? And if you are using the outlier detection mechanism, then that will be filtered, and a huge, I would say, a very, very good data points will be filtered in that case. That will help the model to learn. So if you do the, if you do this, handling the skewed data, if you are handling the skewed data very, very well, then in that case, basically you can mitigate that risk of, having the outlier detected and gone from the data. Now, how these things that I talked about is that, in the previous version was how can we do that? How can we pre-process? How can we handle the potential risks in the numerical data? Now we are going to talk about how can we do the same in the categorical data. Now, for the categorical data, we have already talked about that, the label encoding and the one-hot encoding. We just also saw the example on that as well. So let me just go through that again. So categorical variables, represents the qualitative data, and they require special treatment for them, right? And effective handling of the categorical data is essential for many machine learning algorithms, right? So first one is, remember I told you not every model actually takes, not every model actually takes the categorical data. So those categories needs to be transformed into numerical categories that we can do, with the help of label encoding. As you can see, it says that, assigning a unique numerical label to each category, right? And there are some pros and cons to that as well. Simple, suitable ordinal data, but may, introduce artificial ordinal relationship. That is not very good. And the other one is the one-hot encoding, right? Creates binary column for the, for each category. Binary column means 0, 1 I talked about, right? And what are the pros? So preserve the individual category information as suitable for the nominal data. And again, increases the dimensionality, because if you have 10 different unique values in one column, if you're going to transform that with the help of one-hot encoding, then 10 different new columns are going to be created, which means you're increasing the dimensionality of the data. So these methods should be used very, very cautiously, right? If you already have a very huge amount of dimension in the data, then you should not use the one-hot encoding. Otherwise, that will be, just havoc in the tsunami, right? So let's move to the next thing, handling the categorical data. As I said, again, ordinal encoding we can do, or binary encoding we can do. That we have already seen. Binary encoding means 0, 1, 0, 1. And again, ordinal encoding means the value, the numerical value based on the ordinal relationship that we have in the categories, right? So let me just go through these things: feature transformation, how we do the, scaling and normalization. And so let me just present you the other screen. All right. So let's say I have a feature here. Okay. Yeah. So yeah, I was talking about, let's say I have a feature age, right? And I have a feature income. Right? Now, income, as I said, has a very, very huge range. It can be 0 to, 1 crore, 10 crore, or 100 crores, right? Right? So it could be very, very large, but the age can be, 0 to 100 only, or even it goes to then 120 hardly, right? So this age has a very, very small range, but this one has very, very large range. So what we do is we use the standardization. Standardization means we transform this every feature. So this will also be changed into the standard deviation. STD is going to be 1 and the mean is going to be 0, right? With the help of this, we have also formula for that as well. As I said, you can simply Google it. We have another version that we call the min-max normalization. Which changes the largest value to be 0 and the largest value to be 1 and the smallest value to be 0. How can we do that? So let's say I have a column, let's say 3, 8, 3, 9, 0, 1, 10, 5, right? Let's say 4. Let's say these are the values. If you see, how do we transform a particular value, right? So there is a formula for that. So let's say x hash x dash is equals to x, the current x, minus x min divided by x min minus, sorry, x max minus x min, x max minus x min, right? So let's say I want to scale this 3, right? So this will be x dash for this 3 is going to be 3 minus x min. What is x min? The minimum value is 0. Now x max is 10 and the minimum value is 0. So now we have 3 divided by 10 and this is going to be 0.3. Now if you see the range particularly, so the range is 0 to 10. Now if you just divide by 10 on all the numbers, they said they are going to be changed into a 0 to 1 category, right? So that is how we actually change the values in the range of 0 to 1. Okay. So this is again another formula for min max normalization. And similarly, if we have, I would say, skewed data, then we can also change that with the help of either logarithmic. So if you see the nature of logarithmic function goes like this, and for the exponential function that goes like this, right? So if you have left skewed data, you can transform that with the log, and if you have rightly skewed data, sorry, if you have vice versa, you can think of that. You can actually use this kind of code, right? All right. So yeah, that is how we transform our numerical features. And the next one that we have already talked about, how can we transform our nominal feature, which is nothing but the label encoding and the one-hot encoding and all that. Okay. Moving to the next thing now. We have already seen the standardization, label encoding, one-hot encoding, and ordinal features. Now, feature selections. Now, it is a very, very important step, because remember, when we have a huge amount of features, then selecting our features of our use cases are very, very crucial in that case, right? So the importance of selecting a features is nothing but, very critical step in the feature engineering that focuses on choosing the most relevant and influential feature for the modeling. For example, let's say if I have, let's say 100 different features in a data, but if I see there are, mota 5 to 10 features which will, give us a huge amount of variance, or let's say 99% of the variance, just 5 to 10 amount of features. That's it. So what should we do is we should focus on those 10 features and remove all those 90 features which are not contributing to the variance even 0.1%. So that will be very, very good. But we do it only one way, because 0.1% of variance is not, a very less. That's a very huge when you are going to work for some very, very crucial, models. But it becomes very, less when we have a certain problem with the dimensionality, right? I told about the curse of dimensionality, where you have huge amount of dimension, and because of that, you're not able to learn or run your machine learning model properly, or you're not able to define a complex model for that. Then in that case, what should you do is you can drop the features which are unnecessary and create a very complex model, which can learn the, the trend or the underlying, things in the data, right? So that is called a feature selection. Now, while doing the feature selection, we must do the correlation analysis. Correlation analysis is nothing but finding out the coefficient of correlation with the output that we are going to do. Now, if we have a regression problem, so coefficient of correlation becomes a very, very crucial thing that we have to analyze before eliminating or selecting a particular feature, right? There are two ways to start with, feature selection. First one is the elimination process. We can start eliminating, the feature, the very maximally irrelevant feature, or the very irrelevant feature. We can start removing them. Or the other thing that we can do is we can start selecting the very, very important feature based on the feature importance, right? So these are the things that we do. Now, first of all, we have to measure the correlation. The correlation, if the correlation is high with the output that we are going to do, then in that case, what we have to do is we have to, select that particular feature. If the correlation is not high, then we can drop that, right? So that is the correlation analysis that we do in case of feature selection. Now moving to the next thing, in the feature selection itself, so recursive feature elimination. So I just talked about this one is, first there are two ways for the feature selection. First one is the feature selection from top down, and the second one is the feature removal from the bottom up. Right? So we can start removing the irrelevant feature one by one, and so when it is good, when we have a very complex data set, and it will work with anyone. And This is computationally expensive as compared to the selecting feature, because if you have to select the features, I have to select only 10 features. But if you have to eliminate the feature, then I have to eliminate 90 features in that case. So this is a, again, if you have to remove only 2-3 features, then this becomes very good idea. So it's not just the theory, but everything changes when we have a practical implementation of that, right? So you again, feature importance for the tree-based model. So we have another for a random base or random forest or decision tree models, we have a feature importance. We have a feature importance that we use with the help of entropy. How do we calculate the feature importance? Let me just make you understand that. How do we exactly calculate the feature importance? In order to calculate the feature importance, we use something called entropy. Now, how many of you know entropy? Do anyone know entropy? We might have learned in your let's say high school, intermediate. So entropy is nothing but I would say entropy is something which we the measurement of randomness in our system. So measurement of randomness is something which we if the system is more random, then the entropy is higher. If the system is more suitable, or everything is well designed, fixed on its places, then that the entropy is lower. So we calculate something called information gain. Now information gain will give me the importance of a particular feature, right? So importance of a particular feature can be calculated with the help of information gain. The formula is the entropy of root node and minus entropy of all the child nodes. So this is the information gain. And what is entropy? Entropy is nothing but entropy is equals to summation of I is equals to 0 to C, where the C is nothing but the number of classes. So it will be Pi log Pi. So this is the formula for the entropy. And you can put it here, and then you can get the information gain. Now the information gain is highest for a particular feature, then the importance of that feature is the highest among all. So this is how we actually do that. Now, so that is how we find the feature importance for the tree-based models. Now this thing will not be very good in case of other models. Let's say a feature dependent model. Okay. Now the other one is the dimensionality reduction. I have already talked about this, but there are some methods like PCA and TSNE, which helps us to actually reduce the dimensionality of the data set. So what do they do actually? So in case of dimensionality reduction, what do? I told you that every very important thing in the data is nothing but the variables or variance in the data set that we have. So the variance in the data are nothing but the most important features that we must want to preserve. Now, when we remember that, when we do the feature scaling and transformation, we make sure that the variance of the data, variance of the feature does not change, right? What we exactly do in dimensionality reduction is, let's say, I just gave an example previously that let's say I have a data set with 100 features, but only 5 to 10 or let's say 10 to 11 number of features can cover most of the variance. Let's say 99% of the variance. Means I can explain the output data with an accuracy of 99% with the help of just 10 or 11 features. Then why there is a need of all the other features that we have? And with this principle, we actually reduce the dimensionality. And not that actually, we can create, a new feature by the existing features that we have. We can create a new feature by the existing features that we have based on, their variance, right? And, by just using one principal component or two principal component, or let's say 3 or 4 principal component, again, I can take, that 11 features variance, let's say 99.9% of variance I can take in just 3-5, principal components. So we can create new features, with the help of the existing feature that we have, and we can take the variance of those features into the principal component that we have created. That's called the principal component analysis. The maths behind it is very, very complicated, so I'm not going to touch into that. Again, the other method is T-distributed stochastic neighbor embedding, which is nothing but TSNE, right? This is good for nonlinear dimensionality reduction techniques. Then again, very another technique as this PCA that we have. Now, interactive feature engineering tools, we have, automated feature engineering tools for streamlining the feature engineering process. We can actually write the code and embed in our machine learning or data science pipeline. That will help us to do the feature engineering based on the particular given data. Right? These tools will offer, techniques and automate creation of the creation and selection of the features, saving more time and effort as an individual. Right. So in every programming language or every tool that we implement in for data science or machine learning, whether it is a graphical drag and drop tool or a coding tool, everywhere you will find these kind of feature engineering processes in there. Now, what are the real life applications of them? Basically, we can so healthcare domain, right? Predicting the disease outcomes, right? We have a very huge amount of data. So we have to just bring down to a particular, so that it can be processed, right? And similarly, in the finance domain, credit risk assessment, again, we have a huge amount of data for a particular user, or sometimes we have a very less data. In less data, we have to, analyze that. So we can create new features based on that. So these are, in these different cases, e-commerce and manufacturing, it's just that you have a data and then you are creating or transforming or, reducing these different feature engineering tasks that you are doing. That comes under this real world example of this. So what are the best practices that you can do is that domain knowledge is very, very required when you are transforming the data, right? So if you understand the finance, then maybe you will have to, you can transform the, financial data, credit risk assessment, all of that very, very good way. If not, then you'll have to know that. You will be, if you know the domain, then you will be better than all the others that we are doing by just the EDA knowledge. Right. Exploratory data analysis, I have already talked about this in your previous webinars, that it's a very crucial process that you must do, right? To understand your data. You have to calculate feature importance, cross-validation, and documentation, again, in order to, whatever you are doing, properly document that. Cross-validate whether you are preserving the variance or not, right? Feature importance, when you are selecting the feature, they are important or not. That is what we have to take. Now, what we have to avoid is, we have to avoid overfitting. We have to avoid data leakage or information leakage. We have to ensure that whatever we are generating or reducing the dimensionality, then we are not losing the information in the data. Ignoring categorical variable, we cannot ignore the categorical variable while doing the feature selection or dimensionality reduction. Again, feature selection, we have to select the feature selection and dimensionality reduction. We have to be very, very cautious while doing these kind of processes. So I would say that is it. These are pretty, go through things that we must follow while doing this exploratory data analysis, or I would say the feature engineering tasks. So that is it, guys. Thank you for joining this webinar. Again, if you have any question, then definitely I will be happy to answer your guys.
So guys, that was such an informative webinar, or a masterclass, we can say. So we'll be happy to answer your questions now. So if you guys have any kind of questions related to this masterclass, so you can ask to me or Akash as well. If you guys have any kind of questions, so to ask the question, don't hesitate.
I guess that's it. People do not have any questions, and even if they have, they can ask anytime.
All right. So I guess we can move forward with further more information, as I introduced that we'll be talking more about the collaboration, that how we collaborated with IIT Roorkee, and what advantages you can gain with the help of our new course, which is Advanced Data Science course in collaboration with IIT Roorkee. Akash, I request you to please stop sharing your screen so I can share my screen. Thank you. All right. So, Akash, can you confirm, is my screen visible?
Yes, it is.
All right, thank you. All right, so guys, the moment is here, which for you, for which you guys have been waiting for. So here is our new course, which is Advanced Certification Program in Data collaboration with iHub Sampark and IIT Roorkee. All right. So over here, you can enroll with us, right, and become a certified professional in the field of data science. So for more information, you can easily fill up a very basic credentials or your details like phone number, full name, and email address, and you can download the brochure as well. And I'll be explaining the whole process, and I'll be explaining each and everything about the this program as well, right? So you can download the brochure and share the brochure among your friends and your college groups or whomsoever is interested to pursue their career in science. All right, so directly highlights and takeaways from this particular course. So I already talked about Divya Sampark at IIT Roorkee. So basically, this is a panel under IIT Roorkee which have sources under it. So one of our course under Divya Sampark. Right. So in this course, you'll be trained by the mentors, the industry experts who have several years of experience in the field of data science. And he will not only teach you, but he'll be sharing his industrial knowledge or experience, which can really help you to build your career in the field of data science. Also, once your training period is over, so there will be a placement assistance and mock interviews. So we'll be guiding you to how to perform in place during the placements, and we'll make sure that you crack the placements, and we make sure that you sit in multiple placement companies, right? So coming up to the placement part as well, so there will be different things like group discussion, mock interviews, and how to build your resume before the interview, and how to behave in an interview, or how to sit in an interview. Each and everything will be covered, and what types of questions you should prepare before sitting in an interview. All right, so this was the placement part. Now coming up to the capstone projects and assignments. So this course is not only about the training, but it's more about the practical thing. So once you enroll with us, you will not gain the theoretical knowledge, but you will also gain the practical knowledge as well. So there will be different projects, live projects, which in which the industry is working on. And after each and every module is covered, there will be assignments given to you on which you have to work, and they'll help you out to learn things more practically. Also, along with that, there will be doubt clearing sessions, and obviously mentor assistance will also be there. So in these doubt clearing sessions, you can ask any kind of doubt to the mentor, and he'll be helping you out throughout the program. Also, this course or the program is gonna be live, completely live, and also you'll be having access to our LMS portal over there you can get the recordings of these live classes in case you miss any live class. So you have access of that LMS portal, and you can watch the recording of this particular live class, right? So coming up to the certification part, which is the most valuable thing of this webinar or the program, I would say. So this certificate have lots of value, and it can make your resume look more effective. Right. So as you can see over here, it's written IFDib Hub Sampark, right? So and it's our organization's name is also there, right? And it's a very effective and very valuable certificate, which right, which will be provided on behalf of Scale Vertex and IIT Roorkee, both, right? So this you will receive the certificates once you complete your program and fulfill each and every criteria, which is also mentioned in the brochure, which you can download at the top right corner, right? So coming up to the program, right? So as I told you, go through the brochure for much more idea when it comes to the program thing. Now, coming up to the collaboration part. So how we collaborated and right. So basically, we want to fill a gap between other students and the industrial knowledge or the industrial things which are missing for which are missed out for by a student, right? So this is the main motive of launching this particular program, and IIT Roorkee is helping us a lot to make students learn and gain knowledge in the field of data science. And we have kept a target that we'll make sure that we make several data scientists out of this course, right? So there are so many jobs out there once you complete this particular course. So you can be anything, right? You can be either data scientist, data analyst, and data engineer or machine learning engineer. So once you finish this particular program and get certified with us, so yeah, these are the number of jobs in which you can pursue your career further, right? Coming up to the companies which can hire all these data scientists or data analysts. So there are several companies over here, and I hope you must have seen these logos somewhere in your life. So there are Facebook, IBM, Intel, in LinkedIn, Netflix, Airbnb, Amazon. So all these companies hire data science enthusiasts and data scientists or research analyst, business analyst. So all these job roles are required in such professional companies, right? So you can also sit in these companies someday and uh, do your dream job, right? So coming up to the curriculum, so you can go through the curriculum which is already available on our website, right? You just have to open the website, and over there you can find a option of IIT certification course. So after that, you can go through the curriculum very patiently, right? So here's the whole curriculum, and each and everything is braved out over here. Final projects is also given over there, and what things you will get in each and every module is also given over here. Coming up to the capstone project, which I was talking about, that you will not only learn about the theoretical part, but you will also gain some practical knowledge as well. So these are the projects which you will be working on, and these are the projects in which the companies also play some role. So here are some projects, and you will also get projects related to these topics as well, like credit card fraud detection and news articles classification, and several other projects as well. You can see over here, right? Now, tools you will be learning. So these are the tools and logos of these tools. So it is Jupyter, MySQL, AWS, and many more other tools as well. So over here you can see the people who have already enrolled with us, and they have placed as like junior data analyst, data analyst, data analyst, and this is what they say about the crows and about Skill Vertex as well. Right now, we have already discussed about placement assistance above, and I have already told you about mock interviews, resume building, personality development, and this group discussion as well. Now this same option comes here as well. You can just simply fill up your details, and you can easily download the brochure over here, right? So these are the alumni which I showed the photo of. So we have few people who are working in companies like TCS, Tech Mahindra Delivery, Optum, and several other companies as well, right? So this was it about the whole program. If any one of you have any kind of doubt related to the certification or about this particular program or about the collaboration thing, so you can ask, and please feel free to ask any of your doubt related to the course. All right, so I guess no one is having any kind of doubt. So thank you so much to each and every one of you. It was kind having you all on this master class. I hope to see you further enrolling with us and joining our team, and by enrolling in the program of meeting soon again someday. So thank you so much. Have a great evening ahead. This was it.